So this is the project management side of the concrete strength project. In this, our first step was to create a lit review. Firstly, we went through the links provided in the IPYNB file and organized relevant data by article, anything that would be used for the eventual final lit review was organized over here. Once we had finished gathering this data, the lit review was drafted and then edited to create the final report in which we provided background knowledge on concrete strength and the testing process and the different things that make up concrete, and overall stated our plans for how we were going to execute this project. After the steps were outlined and detailed and all of our background knowledge was applied in this review, we were then able to go into creating regression models for the data that was given to us in the Excel file. And from the given Excel file, we then tried 5 different regression models and to see which model would give us the best fit. Once that was determined, then we used that model that we had chosen to first test it using the data from the Excel file, and was then tested to see how accurate it would be. And once we determined that it was accurate enough, then the final data model.
We know from our previous required research that this is a linear regression problem. So the first thing we're going to do in order to build our data models are we're going to obviously read our data and put it into a data frame. And while we're at it, we might as well rename the column names because they are extremely long. The next thing we're going to do is we're going to separate the data into our features and our target. So our features would be cement, blast furnace slag, fly ash, water, sewer plasticizer, coarse aggregate, fine aggregate, and age. And our one target would be our concrete strength. The next thing we're going to do is we're going to have to separate our data into training and testing in order to get good performance out of our data model. And then we're going to scale our data, that way the features have a standard deviation of 1 and a mean of 0. Next thing we're going to do is we're going to import linear regression, lasso regression, and ridge regression from sklearn, and we're going to put them into variables, that way we can call them later. We're going to call them right here as we fit the training data into the models. As you can see, we use linear regression, lasso regression, and ridge regression. And then we're going to make our predictions. And we're going to use these predictions to kind of see how good of a fit that these data models are. So our first one that we're going to see is we're going to see linear regression. And as you can see, it's not that good. What we want is we want a straight line right here along this line, and we want a best fit. So this is okay, but we could do better. So let's try our next one, which is lasso regression. And this is probably worse. So let's go to the next one. So the next one is ridge regression. Okay, we're getting somewhere here, okay, but we think we could do better. So we went and decided to do a decision tree, which builds a tree upon the data and can further accurately predict the data. And decision tree is often used to solve regression problems and classification problems. So we knew that this would be a good fit. So we went ahead and fit the decision tree on our training data, and then we're going to predict it using the test data. And let's see what it looks like. And as you can see, it is a lot better right here. But there's one more thing that we could do, and we can add more trees. not just one tree that this builds upon, we can add more, which would further increase our accuracy of our predictions. So let's do random forest regressor, and let's see how it looks. And wow, yeah, it looks a lot better than it normally would. So let's see the root mean squared errors, and as you can see here, lasso regression actually has the highest root mean squared error, and random forest regressor has the lowest root mean squared error. So we know that that is a good model to use. So with that being said, let's go ahead and implement our random forest regressor data model into an interface. That way we can predict the compressive concrete strength based on specific values. So the first thing we're going to do is, since this is a new notebook, we're going to go ahead and have to redo some of the stuff like reading the data into a data frame and renaming the columns. So this is where we did that, and then we also have to separate the data into two groups once again, and also train our model once again. And finally, here is our interface where we will predict the concrete strength. And so we have variables, and we just put the variables into the prediction tool. That way we can get our strength, our estimated strength. So let's just do that real quick. Let me just show you how it works. So you just run it real quick, and then you enter random. Let's just see. Let's do number 4. Let's do 198.6. This is just doing this to compare it to a known CC strength, just to see how good this model really is. 132.4. Okay. And then we have fly ash 0.0. And then we have water 192.0. And then super plasticizer 0. Coarse aggregate 978.4. 978.4. Fine aggregate 825.5. 825.5. Let's do age, which is 360, and we should get our estimated strength, which is 43.04, which is about 1 off of the known. So pretty good, pretty good. And here I was going to test at least 2 of these, but due to time constraints, I'm not able to. So let's just move on to our interface to add the data to the data frame. So here it's pretty simple. We just have our variables, and we add these variables under the column names, as we can see here with our variable of observation, and then we're going to append this, the observation variable, into our data frame, and then we're going to show our data frame to make sure that the data was added correctly. So let's just go ahead and input random numbers. Let's do 45, 33, 55, 44, 66, 55, 44, 77.56, 53, sorry. I mean 43, my goodness. And then let's enter our CC strength, which would be 90, I don't know, something. It's not accurate, I'm just putting random numbers in. Let's see, did it add it? Sure did. Row 1030, it added these data that we added. So, but that is all. So thank you very much.